Hello friends, welcome you all on YourPedia Education. So friends, as you know that concept through question series is going on YourPedia Education, and I have already uploaded 2 videos on theory of machine, and today I am going to cover one more topic, that is inversions. Okay, so in inversions, let's see the various types of inversion and some questions on that. So if you have not subscribed to the YourPedia Education channel friends, so first of all subscribe it so that you can see the more concepts, more information related to the jobs and interview experience of the students, and more useful data for all of you. So let's start. So here you can see inversion of 4-bar chain. So what is the meaning of inversion? I have already explained you in the last video that if you take a mechanism, suppose this is the mechanism. Okay, so this is a 4-bar mechanism. I can say these are the 4 bars. So if you fix this link, then you will get some time of mechanism. Suppose this link will going to completely rotate, this link will oscillate. So I can say if you fix the largest link or whatever the link is, suppose this, if you fix link A, this is B, this is C, and this is D. So if you fix link A, then one link is crank, that is fully rotating, and another link is oscillating, I can say. Okay, so oscillator and crank, you are going to get inversion. So if I talk about inversion of 4-bar chain, 4-bar mechanism, then there are 3 inversions possible. Okay, first is double crank, that at least 2 links, basically 2 links are rotating in this. And second is crank and rocker, one link is rotating and another is oscillating. What is the meaning of crank? Crank, it is complete rotation by 180 degree. Okay, and what is the meaning of rocker? Rotation but not completely. Rotational angle is less than I can say this is 360 degree, and it is less than 360 degree. And what is the meaning of a double rocker? That 2 links are basically just rotating at angle less than 360 degree. And remember that in this mechanism one link will be crank. Okay, one link will be act as crank because 4 links are there na. So out of 4, 1 is fixed and 2 are rockers, and remaining 1 is crank. Okay, now inversion of slider crank mechanism. So 4-bar mechanism has 3 mechanism: double crank, crank rocker, and double rocker. And inversion of slider crank mechanism, what is slider crank mechanism? This is slider crank mechanism, this. Okay, so it is crank and it is connecting rod and it is piston and it is fixed link. So if you fix link number 1, what is the meaning of link number 1? This is link number 1 fix. Then the inversions that you are going to get, or if you fix the link number 1, then that inversion, or depending upon the inversion that you get by fixing the link number 1, the applications are IC engine, reciprocating compressor, punching machine. Here you can see if you fix link number 1, this is the mechanism that you obtain. So this mechanism you use in IC engine also, reciprocating compressor also, and punching machine also. Now if you fix a link number 2, that is crank, then the mechanism that you get is Whitworth quick return mechanism and rotating engine, and this mechanism is used in shaper. Okay, in shaper. And then link number 3. So in link number 3, if you fix this link, okay, if you fix this link, then crank and slotted lever mechanism that you are going to get, and oscillating cylinder mechanism you are going to get. Okay, so these are the 2, and remember that in crank and slotted lever mechanism again you are going to get a quick return ratio, and it can also be used in shaper. And by fixing the link number 4, that is by slider. Okay, when I fixing the link number 4, remaining links are free to move. So the mechanism that, or the inversion that you are going to get, or the application of this inversion is hand pump. So in a slider crank mechanism, how many inversions are there? 4 inversions are there. First question can be asked from this. And in 4-bar mechanism, how many inversions are there? 3 inversions are there. Now inversion of double slider, last में हमने क्या पढ़ा? Inversion of slider crank or single slider, it is also called single slider. But if I talk about this inversion of double slider, now double slider mean the first inversion is basically this is the double slider. So isme first inversion is elliptical tremble. Basically it is instrument used to drawing of ellipse. So here you can see this is the geometry, this is point A and this is point B, and I can say this is link number 1, that is fixed. Link number 4 is I can say this slider, link number 3 is this connecting rod, and link number 2 is this slider, and these are the points. A is point on link number 4, and B is point on link number 2, and C is somewhere here. So when you basically rotate this like this, then if you fix a pencil on this point or pen on this point, then this point will trace a path which is I can say the shape of ellipse. Okay, so it is called, that is why it is called elliptical tremble. Now question can be in the form of that what is the major axis and minor axis, or semi-major and semi-minor axis of the ellipse that is formed by this mechanism, that is elliptical tremble. So AC and BC, okay, AC and BC are semi-major and semi-minor axis. So AC distance, this distance is semi-major, and BC is a semi-minor axis. So this is semi-minor axis. So this is semi-minor and this is semi major axis. Okay, so I hope you get the idea about this. Now if you want to find the major axis, then just multiply it with 2, you will get the major axis, and multiply it with 2, you will get the minor axis. And if you basically plot this point, if you take a point at the center of A and B, then the shape made or the path traced by this point P is called circle. Okay, so P is the midpoint of link AB, will trace a circle. So these points are very important, from which directly question can be framed. Now next is Scotch yoke mechanism. Scotch yoke is like this. Okay, there are two sliders are there. First slider is this. Okay, here you can see this is sliding, this purple color is sliding like this. Okay, and second slider is this. Okay, so these are the two sliders. So this mechanism is used to convert rotary motion into reciprocating motion. So directly question is basically Scotch yoke mechanism is inversion of single slider, 4-bar mechanism, or double slider. So answer is double slider. Its application is door lock also. Okay, its application is door lock also. Now next is the important application of this Oldham coupling. Now Oldham coupling you all have must be read somewhere. So an Oldham coupling is used for connecting two parallel shafts whose axes are at small distance apart. Okay, because its axis is this and its axis is like this. Okay, so axes are small distance apart, so axes are not, I can say, co-current. So the shaft are coupled in such a way that if one shaft rotate, the other shaft will also rotate at same speed. So maximum sliding velocity of each tongue. So here you can see this there is some link. Okay, so there is a fixed link also there, like this fixed link and link. So fixed link is 1, this is called 2, and this green color is called third link, and this is link number 4. Okay, so 4 links are there. So this green color link have some projections like this. Some projections are there. Okay, so there are two projections, this and this. So it is called tongs. So here you can see green color link is just sliding like this. Okay, so it is sliding like this in this direction. So the velocity of sliding is omega into r. So omega is the angular velocity of each shaft, and r is the distance between the axes of shaft in meters. So this distance is called r. Okay, now let's move to the question. Which one of the following mechanism represent an inversion of single slider chain? Single slider chain. So it is called a single slider chain, not double slider. Elliptical tremble, answer is not. It is double. Oldham coupling, no, it's double. Whitworth quick return, yes, it is basically inversion of, I can say, single slider. Pantograph, answer is no. Okay, so its answer must be option number C. Now next is the number of inversions of a slider chain mechanism. So how many number of inversions are possible for a slider chain or single slider? So answer is 4, that we have discussed. Now which one of the following is a curve traced by a point on the connecting rod of a double slider crank chain? So which one of the following is the curve traced by a point on the connecting rod of a double slider chain? So it is not given that point is at a center or anywhere else, so we have to assume that it is out of the center and the path traced should be ellipse. Okay, next is which one of the following mechanism is a inversion of a double slider? Inversion of double slider. So elliptical tremble is basically answer of double slider mechanism. Okay, Now we have basically discussed that in pantograph all the pairs are turning pair, spherical pair, sliding pair, or self-closed pair. So let's see what is the meaning of pantograph. So this is a pantograph mechanism. A pantograph is a instrument used to reproduce an enlarged image on reduced scale, okay, on or on reduced scale. Because if you want to make any scale larger, or if you want to make any scale image or whatever the scale on a smaller scale, then you can use the pantograph. It is basically also used at the top of the train, okay. train में जो इलेक्ट्रिक ट्रेन्स आर देयर, उसमें जो ऊपर वायर से करंट आता है वो पेंटोग्राफ मैकेनिज्म यूज करते हैं. सो दैट इज ऑल्सो द एग्जांपल ऑफ दिस. सो ये क्या करेगा, दैट उसी इमेज को, वट एवर द इमेज, सपोज यू वांट टू कन्वर्ट दिस इमेज into larger, then you can use pantograph, okay. By using pantograph you can make the exact larger size image, okay. So this is the application of this, okay. So one pencil is connected here, one pencil is connecting here. So here you can see this is the enlarged image, small line, and it is a large line. So pantograph ne all the images are all the, I can say, pairs are turning pair. One turning pair is there, one turning pair is there, one turning pair is this, one is this, one is this, and this, okay. So all pairs are turning pairs. So option number A, okay. So next is basically, here you can see pantograph used to collect power at the top of electric locomotive. Which of the following mechanism is made up of turning pair only? Scott-Russell mechanism, Precalure mechanism, or Hart's mechanism. So let's see. Here you can see Precalure mechanism is this. Point B traces straight line path perpendicular to diameter OP. So it is just used to draw the straight line. And Hart's mechanism, point B will trace a straight line perpendicular to line OP. So it is also used to draw the basically straight line. So I can say Precalure mechanism and Hart's mechanism, okay. So these both are made up of a turning pair, and I can say here you can see mechanism path line perpendicular to OP, and Hart's mechanism point B will trace a straight line perpendicular to. So here you can see all the pairs are turning pair, all the pairs are turning pair. So I can say if this is also a turning pair, this is also a turning pair, and in this it is also a turning pair. So I can say none of these is option, okay. It must be either this option must be A and C, or A and B, and whatever the option are there, okay. So this question need to be some correction. Now next is, which of the following mechanism used to enlarge or reduce the image? That we have already discussed, sir. Pantograph is used to enlarge or reduce the image. Here you can see. So friends, this is all about today's this video, and this is a very short video. I have tried to cover just a basic concept. Here you can see, you have to just see this slide, this slide, this slide, and this slide, okay. So if you see these 4 to 5 slides, you will just able to attempt all the questions related to the, I can say, inversion in theory of machine. So we will meet in the next video, friends. Thank you very much.